it says here that we got a equals 25 times 10 to the power 14n, where n is an integer. Now, find an expression in terms of n for a to the power 3/2. Give your answer in standard form. Alright, so all you have to do here, to get a to the power 3/2, literally copy this expression, 25 times 10 to the power 14 to the power n, wrap it around in a bracket, and put power of 3/2, because that's what they want. Now, just like normal indices, when you times something by power, you attach it to every term. So we're going to have now 25 to the power of 3/2 times 10 to the power 14n, and because the powers are on the same line, well, they should kind of be in the same line, it will be times 3/2. Now we just evaluate them individually. So for the first bit, this is dead easy. Just smash in your calculator, you should get 125 times. Now for this part, you just multiply head on. So it's 14n times 3/2. Well, in your calculator, just write 14 times 3/2, and you're going to get 21, so 21n. Now, usually this would be the end of the question, but because they got standard form involved, this means that we need to make this first term, the first set of numbers, less than 10, yeah? And to do so, we need to rewrite it as 1.25, because this is less than 10, bigger than 0. And when you write this, you'll realize that you took 2 tens out of this. So we're going to give these 2 tens to this power, so it'll be plus an extra 2 tens. And that's it, guys. This question is done. Alright, number 21. So a curve has equation y equals fx. There is only one maximum point on the curve. The coordinates of this maximum point are 4, 3. So x is 4, y is 3. Write down the coordinates of the maximum point of the curve using the following two. So we just need to be comfortable with transformations here, yeah? So it's telling us in the first transformation that we now have fx, which becomes fx minus 5. So inside the bracket, when it says x minus 5, we do the opposite. We're now going to add every x coordinate by plus 5. So this means we look at 4, 3, just add 5 to the x coordinate, and it's going to become a 9, 3. And that's it. For the second part, it says 3 times the function. So since y equals that function, we're going to multiply all the y terms by 3. So looking at its coordinate again, timesing the y coordinate by 3, we're going to get 4 and 9. Yep, and that's it for part A. Now moving on to the next part, it says here is the graph of y equals a times sine of bx for x range of x value between 0 and 360 degrees. Now, okay, we got this kind of sine wave graph, but it looks kind of upside down. Find the value of a and the value of b. Alright, so to do this, we need to first remember what a sine wave graph looks like, yeah? So what I do is always sketch it to the right, like something like this. And we know that it's a wave starting from 0, one shift and another shift here, where the maximum point here and the minimum point here matches at 90 degrees. This intersection is 180 degrees and the minimum is 270, and it ends at 360. Okay, so looking at both graphs for a second, one more key aspect is that the maximum on the y-axis is 1 and the minimum on the y-axis is -1. So this is going to literally give us an indication how to solve this one. Now looking at your original sine x graph and comparing it to this other shape, you can see that instead of going upwards, it's going downwards. And notice how it stretches all the way to 2. This means that actually that the entire sine wave has been inverse, so it's actually a negative sine x. But because it's going downwards and it goes down to 2, it's been scaled by 2, by a scale factor of 2. So we know straight away that a must be a -2. Okay, so because it's been scaled by 2 times. Now, as for the loops, notice how we just do one loop up and one loop down. We've actually done how many loops? 1 down and 1 up, and another one, 2 and 3. So actually we've done this 3 times to get to the 360. And because you've done 3 loops, this means that the value inside the bx must be a 3x. So b is 3. And that's it. These are your 2 answers. Alright, number 22. Solve the simultaneous equations. Show clear algebraic working. Alright, cool. Now to solve this nice and easy, and actually they've already done this for us. Usually what you would have to do is make one of these letters a subject, and they did it. They made y the subject here, and then substitute back into one of the other equation. Since y equals a subject, we're going to replace this y here with 2x plus 1. So this means this entire first equation now is going to be 2x squared plus 3, and notice is y squared. It's going to be all of the y term, which is 2x plus 1 squared, and that's going to equal to 5. Now all you want to do here, expand this, so, and then just keep simplifying until you get some terms in terms of x, some equation in terms of x. So therefore, expand this carefully. You still got 2x squared here, 3, and notice you got a squared bracket here. This is basically 2x plus 1 times 2x plus 1. I'm going to do the working out here, So to expand this, just use the FOIL method, multiply this with that, and 2x of 1, 1 of 2x, 1 of 1. Doing 2x times 2x is 4x squared, 2x times 1 is 2x, and then same thing, 1 times 2x is another 2x, giving you 4x in total. 1 times 1 is plus 1. And now we're going to multiply all of this by 3, yeah? So therefore, 3 times all of this is going to give us 12x squared plus 12x plus 1, and that's all going to equal to 5. Now, one thing you have to always observe for these ones is that this is going to make a quadratic equation, yeah? So what I would do is collect like terms and make it equal to 0. So 2x squared plus 4x squared is going to give us, 2x squared plus 12x squared is going to give us 14x squared plus 12x. Now we got plus 1, subtract the 5, you get minus 4 equals 0. Now, for this one, don't bother simplifying too much, just jump straight to the quadratic formula, yeah? So using the quadratic formula, if you remember it, it's going to be x equal minus b plus minus square root of b squared minus 4ac, guys, yeah? All over 2a. And then substitute all your values in, where a is 14, b is 12, and c is minus 4. You're going to get something like, let's do it, minus 12 plus minus square root. So 12 squared is 144 minus 4 times 14 times negative 4. So yeah, for this case, always wrap your negative in a bracket, all over 2 times a, so 2 times 14. Yeah. And then if you did this carefully and correctly, you should get 2 answers in your calculator. That is the first x value. When you should get 1 over 7, and you should also get, if you try the other sign, negative 1. Or I mean, one of these signs you get one or the other. Okay, so these are your 2 results. Now, it doesn't stop here, yeah? Since you got your x values, you also need your y values, because the solution always has 2, yeah? Now, what I would do is, since we got x values, I'll look at the original equation and ask myself, which one looks easy to work with? Well, this is definitely easier, because y, it's a linear equation, and it's already equal to y. So all you got to do is replace this x value firstly with 1 over 7 to get an answer. So doing so, you can have y equal 2 times 1 over 7 plus 1. It's going to give us 9 over 7. So that's the other pair that goes with this. And the next one, replace x with negative 1. 2 times negative 1 plus 1 will give us another negative 1. So y also equals negative 1. And that's it, guys. That's this wrapped up. All right, guys. Number 23. Let's go. So what do we have here? So it says here, B, C, D, and F are points on a circle. A, B, C, A, F, D, and the rest are straight lines. So basically all of these are straight lines, yeah? Work out the size of angle X. Show your working clearly. Right, so yeah, so circle theorem. So for these kind of questions, it's always important to know as many properties as you can, yeah? But let's just have a go and see what we can find. That's the best way to do these questions. Now, first thing I want you guys to know is that inside the circle, we have a 4-sided shape. And we have a cyclic quadrilateral, which touches at every corner. Okay, so when it does that, that is literally the cyclic quadrilateral right here. And one of the properties is that when you got an angle on one corner, and its opposite angle, which is another corner, must sum up to 180, yeah? So this is x, and we don't know what this is. This must be, let's call this y. These two must add up to 180, okay? Now, in this case, because you want your answer in terms of x, we can just make y the subject and say, all right, y can equal 180 minus x. So let's put this over here. We'll call this 180 minus x. Now, next step. So same thing applies there, yeah? So this is also cyclic quadrilateral, but we're not going to worry too much about that. We're going to actually work with this 54 here now. Now, look at this triangle head on, yeah? So let me just do it carefully. From A all the way to C, all the way to D. This straight up triangle, let me just resketch it here. If we know that this is 54, this is going to be y. This is going to end up becoming the difference of 54 and that value there, yeah? So let's see. Just give this another layer. I'll call it Z. So therefore 54 plus y plus z must equal 180. Now the trick is, guys, if you get as many questions, as many values as possible, then you've got this, yeah? This is pretty much solved. Now let's look at the next one, the 32 degrees here, yeah? What else do we have? So let's see. So we've got 32, so we can make another triangle. So if you go from B all the way to E all the way, oops, that's so bent, and then E all the way to C, that's another triangle formed. So you got B, E, C. You know this is 32. This is X, so that's already given, and this is Z. Done. And we know that these three must add up to make, what's it called? 180. So X plus Z plus 32 equals 180. Okay, so far so good. What do we do now? So now we got a bunch of equations here. We got equation 1, equation 2, yeah, equation 3 as well. And now all we could do is substitute these back into each other, and then you solve them simultaneously. Eventually you should get an X. So what I'm going to do now, I'm going to substitute this equation involving y into this equation over here. This will reduce this equation to 54 plus 180 minus x plus z equal 180. And on both sides we can subtract 180, so these two cancel out. This becomes 0 here now. And now we could just, what? We can move minus x and z to the other side, so we're left with literally x minus z equals 54. Or whatever, you're going to get an equation that looks a bit like that. You might get 54 minus x plus z equals 0. Just rearrange it in a form you like. And now looking back at the top left equation here, just subtract 32 across, so you're going to get x plus z equal 180 take away 32, I think is 148. Okay, good. Now, what do we have here? So it looks like we got two simultaneous equations, one with x plus z, one with x minus z. So let's go put the x minus z equation below this equation here. And then what we're going to do, usually we add or subtract, right? Solve them simultaneously. In this case, I want to get rid of the z, and the only way to get rid of them if you add across downwards. So adding downwards, x plus x is 2x, z add minus z gives you nothing, cancels out. And lastly, 148 plus 54, and I did not calculate that, will give you 202. And that's it. And then dividing 2 across, you're left with x equals 101 degrees. And that's it, guys. We are done. All right, guys, number 24. So what do we have? It says here that P is the point on AB such that the ratio between AP to PB is 3:1. Just looking at it closely, this is talking about from here to here. So if this was 3 parts, this would be 1 part. So if this was length A, this would be 3A, if it was like that. And it says here that Q is the point on AC such that OQP is a straight line. Okay, all right, cool. Is this a midpoint? I'm not too sure. Use a vector method to find the ratio between AQ to QC. Okay, so they don't tell you. So we need to figure out what it is. But it kind of looks like a midpoint, but we can't assume that, yeah? Okay, so just looking back at the question one more time, yeah? It tells us that Q is on the point on AC such that this line, OQP, is a straight line. So OQP is basically this, yeah? O to Q, Q to P. Now, how do you know something's a straight line? It's only a straight line in terms of vectors if they're both moving in the same direction. So this is kind of what we need to get here. The other piece of information we had earlier is that A to P and P to B is in the ratio 3:1, and we did that over here. Now, since we know that the whole from A to B is 2C, that means one part out of the total 4 parts must be, well, 1/4 of 2C, which is 0.5C, and that means the remaining must be 1.5C here, because these two sum up to make 2C. Now, we also need to kind of define, I don't know, figure out what AQ is or something, yeah? Because later on it tells us to use a vector method to find A to Q to C, okay? So let's just give this let's just give this a proportional length, yeah? Let's say, all right, let A to Q be, I don't know, some K, like some scale factor K of the whole A to C line, yeah? The reason why is because we know how to find A to C, where A to C, and this is not too bad. You start at A, go all the way to C, so you go back in this direction, minus A across plus C, or just C minus A. Therefore, A to Q, A to q is going to be k, some scale factor k times the vector c minus a. Okay, now what is next? Well, we're trying to show that firstly we have a straight line here, right? And we're trying to find a ratio. Let's find, I don't know, o to q now, yeah? Since we got enough information. So o, that's to q again. O to q is, how do you go from o to q? Well, we can go up by a and then following that aq root we found. So it's just a plus the aq root, which is k c minus a. Okay? And just tidying this up. You can expand this, so you're going to get a plus kc minus ak, collecting in terms of, because for these kind of questions we must always keep in terms of vectors, yeah? So we're going to have basically factorize the a out. We're going to have 1 minus k plus kc, yeah? I'm going to put a little line for the vectors now. So that's what's it called, OQ done. Let's find QP. You're going to see what's happening in a second, yeah? Remember, we're trying to show that this is a straight line. And their straight line is basically O to Q is some factor of O to P, is some proportional factor, yeah? So QP, we're going to go back through the AQ root, but backwards. So instead of K C minus A, it will just be K A minus C. Or you can just put a negative sign instead. Plus 1.5 C. So remember, this is in this direction, yeah? 1 plus 1.5 C. Okay, so far so good. Now to relate them, we can say, alright, we can say that, I don't know, O to Q is basically some scale factor now, n, of the whole line O to P. Okay, and what this tells us, just replace everything. Since we know what, since we haven't actually obtained O to Q, oh no, we have obtained O to Q. Since O to Q is all of this, which is A1 minus K plus, I'll put C in front, CK, and O to P, so n times, so O to P is basically going all the way here and then all the way across to P. That's just A plus 1.5 C, and since you're times it by n, it will just be NA plus 1.5 NC. Now we're almost done, yeah? So this is where vectors get a bit more interesting. So you see what we have here. We have basically two unknowns and a relationship. We can say, now in terms of vector A, so looking at vector A on both sides, we have 1 minus k on the left and it must equal n on the right. Looking at vector C, we got k on the left and it must equal 1.5 n. Okay. Okay, now what I could do, I could just divide 1.5 across. So dividing 1.5, you're going to get 2/3 k equals n. So just put this in the calculator, 1 over 1.5. And now I'm going to substitute this equation into the first equation. So basically, replace n with 2/3 k, yeah? So you're going to get 1 minus k equals 2/3 k. And now we just solve for k. So let's have a look. So you can plus k to the right. So that's plus 2/3 k plus 1k gives you 5 over 3k, which equals the left-hand side, which is 1. I just flipped it around. And finally, just times 3 divided by 5. K is going to equal 3/5. Whew, yeah, we done it. So we just literally found out that, okay, since this is 3/5, we just found out that AQ is 3/5 of the line AC. So this is 3/5 of AC, meaning this is 3 parts, and this must be 2 parts because 2 plus 3 gives us a total of 5 parts. And that's it. So the ratio from A to Q to C is therefore 3 to 2. Whew, yeah, we did it. Anyway, guys, that's this question done. Please leave me some comments on this one. Tell me what you think. Let me know if this is the actual right answer, because I haven't had time to check the mark scheme since I'm trying to do this quickly. But yeah, let me know, guys, and let's move on to the next one. Alright, guys, number 25. Let's do this. So a boat sails from point X to point Y and then to point Z. Y is on a bearing of 280 degrees from X and Z is on a bearing of 220 degrees from Y. Okay, so let's stop there for a second. When you deal with bearings, you always start from the statement where it says from something, because that's where you begin. You never start from Y to go to X, you go from X to go to Y, so from. So what I would do, just put a little coordinate here, X, just draw a north arrow, let's call this X or something, and we want to do a 280 clockwise degree angle, yeah? So think of it this way. So you know you got one right angle here, which is 90, 180, and then 270, so yep, the line's coming up over here. So we're going to draw a line, something like that, with an angle of 280 degrees. meaning this little gap here from to the north line, 2a plus 80 degrees will give us 360. Because remember, all angles around a point add up to 360. So now this point here, so we're now at, where is it, at y, yeah? So this is y. So let me label this x, this is y, and here's our, okay, y. And here is our north line here. Let me just put the arrow up. Okay, now it tells us on the next one, y, so from y we go 220 degrees to z, yeah? So let's do it again. So from here you go 90, 180, 270. So it's basically like here. This will give us an angle of 220 degrees. Okay, and just a quick recap, yeah? And yeah, this goes to point z. Therefore, we can just now connect it to x, if it's a triangle, but I've read it, that's what it is, x, y, and z. So so the purpose of this question, they probably want you to make some kind of triangle, use cosine and sine rule, and then get the thing done. But let's break it up a bit, yeah? Since we know, like, in this kind of shape, this is some sort of allied or corresponding angle, the sum of these two angles must make up 180, yeah? Since this is 80, this is going to be 100 degrees, meaning this little remainder here, since the whole thing is 220, this little gap must be 120, because 220 take away 100 is 120. Okay, so far so good, yeah? That's all the gaps so far. Now, what do we have? So the next statement tells us that the distance from x to y is 3.5 kilometers. So that's this line here, 3.5 kilometers. And from y to z is 6. Okay. So far so good. So let's just refresh that again, yeah? So you got, oops. So you got 6, 3.5, 120. And we're trying to find, what is it? Work out the bearing of z from x. So we need to go from x and see how long it gets to angle to this line connecting to z. So we're going to find this part. Okay, and the only way to find it, if you work out this unknown angle here first. Let's call this one theta, yeah? Okay, now at this stage, all we have to do is basically pick either the sine or cosine rule and find what we need. Well, unfortunately, with what we got so far here, we can't work out theta because to use a sine rule, we need matching pair of angle and length. We got 6 and theta, but we don't have something 120, and we don't have 3.5 with another angle. So what we could do is use the cosine rule and try and work out this unknown length here. So let's call this unknown length x, yeah? So we can now use basically 6, 3.5x, and angle 120. So the cosine rule was something like that. It was a squared equals b squared plus c squared minus 2bc cos a, yeah? Where a is the angle of interest, which is 120, and little a is opposite the angle, which is x, meaning b and c will be 6 and 3.5. So therefore we can say x squared equals 6 squared plus 3.5 squared minus 2 times 6, 3.5, and cos 120. Okay, so when you put this in a calculator and then square root your result, I've done this already, you should get approximately 8.3 kilometers, yeah? So this should be fine. So now we know what x value is. So this length here is 8.3-ish, yeah? Okay, perfect. Since we got this value, let me just update it here. So you got 8.3. Now we can use the sine rule, yeah? So we can use the sine rule and match two pairs. Let's match 8.3, 120, and 6 with theta, yeah? So I'm going to do sine theta over its opposite, 6, equals sine 120 over its opposite, 8.3. Then you multiply 6 across and then sine inverse, yeah? So sine theta equals sine 120 over 8.3 times 6. Put this in your calculator and use a sine inverse bond, so sine -1, yeah? So this in your calculator. And you should get a theta result of, again in this case, approximately 38.6 degrees. Alright guys, so almost done now, yeah? Almost done. So just looking at it again one more time, yeah? So this angle here, let me just fix it up a bit. All of this is 38.6 degrees, yeah? And just remember, we're trying to find a bearing from what? What was we trying to find a bearing from? Oh, I can be lost. Okay, work out the bearing of z from x. So we're from x, which is here, this line here, point here, so we're going to go basically like that. Since we know all the way round up to here is 280, we can work out that this angle here must just be 280 take away 38.6. So therefore the bearing is going to be the difference between 280 and 38.6. And this, my friends, should give us 241.4 degrees. And that's it, guys. We're done. Yeah, give it to one decimal place and you're good. But anyway, thank you for watching, guys. I hope you guys have been patient and enjoyed these last two questions. In particular, I'm not gonna lie, the vectors in this one was kind of hard. It took a while. It takes a lot of thinking. But if you have any questions, please let me know and we shall go through it together. Otherwise, I shall see you guys next time. Ciao.